All right, good morning, everyone. This is Mr. Who, back at it again with some more pre-calculus. Now, last time, we kind of heard about these things called sequences, these lists of numbers, okay, where you're trying to get from one number to the next using a common difference or ratio, depending on whether you're talking arithmetic or geometric. All right, so I'm going to remind you of those formulas real quick, since that is basically what we're going to be building off of here. First of all, if you want to find any number in the list, a sub n, it's going to be taking the first number in the list, a sub 1, sorry, that's like a 1, plus some common difference times n minus 1. So depending on what number you're looking for, you're going to be adding this number, this difference, a number of times minus 1, right? And similar for the geometric, except instead of adding and subtracting and all that other good stuff, we're going to be looking for the first term times some common ratio raised to the n minus 1 power. Okay, so it's a little different, but hopefully you remember what these look like since you were supposed to have done them last time. And I mean, you may have remembered these from Algebra 2 even. They might even look a little different depending on the numbers, the letters, variables we used, but same idea there. Now, when we move on to series, okay, we're going to keep these forms in mind, but we're also going to learn about different formulas and different ways to perceive or show the problem. Okay, but a series essentially is a sum of a sequence. Okay, or I guess terms in the sequence. Okay, sum of terms in a sequence. So right here you can add that in there. Sum of terms in a sequence up to a certain point. Okay, so today we're mostly going to be talking about finite series. So this splits into two different types. There are finite series. Okay, so these end. Okay. And then there are infinite series, which we're not going to talk about right now, okay, which these also sometimes converge, okay, converge or diverge, okay, and we're not going to talk about that too much because the delta method does not support this one right here, unfortunately for us. So if you're interested in this topic, okay, maybe you can search it on your own here and talk about that later if it really interests you, but for the most part, we're going to be focusing on finite here. So I'm going to give you the formulas. Okay, I'm going to give you the formulas for these series, but do know that we're going to be dealing with this idea of a summation. So if you guys don't remember that, I'll get to that in a little bit. But here are the formulas for arithmetic and geometric series. First of all, I'm looking for a sum, so sum of n, sorry. Okay, and what I'm looking for with an arithmetic series is the number. Okay, so that's whatever you're looking for, how many numbers you're summing up. And I'm going to be multiplying it by the first term plus the last term, all divided by 2. Okay. So a pretty innocuous formula there. I'm going to go ahead and label all of these pieces with a different color. Okay. So this is the first term in the sequence. Okay. Use a different color here. This is the last term you want to sum. All right. Not black, I want a different color. And then this is the number of terms total. Okay. And then of course this over here, this S of n, is what we're looking for. This is our sum for the series. Okay, so I'm going to talk about these each individually after I write them down here. I'm just putting them out here so you kind of know what we're getting into. For geometric, this formula is a little more complicated. This formula is a little more complicated. All right, so we're going to start with the S sub n. Okay, that's what we're looking for, the sum of the series. Okay, and that's going to be equal to our first term, so a sub 1, multiplied by 1 minus r to the n power, okay, all over 1 minus r in parentheses. So this is a very different looking formula, and one that is probably going to need a calculator to do. You may have already needed a calculator to do the sequences, so please have a calculator out to help you with this one. But I'm again going to label all these things. We have our first term right here again, our a sub 1. Okay, there is no last term this time. Okay, again we have n, which is the number of terms in the sequence. And then we have R. So R, remember, is our common ratio from above. So you will definitely need to figure that out going forward with the geometric series. Okay. But that is what we got going on here. And of course, this is, again, the sum or series. Okay. Okay. The series that we're looking for. So a little bit different. I just wanted to get those out there so you guys have something to look at. I'm going to have them posted on the video throughout the whole thing. I'm going to be rewriting it over and over again so you guys know. Now let's go ahead and move on to the next part of the lesson. Alright, so just as promised, before we get into any more series talk, I do gotta mention this summation notation idea. So, first of all, there is this very funky little Greek letter called a sigma. It looks kind of like this. Alright, and usually in math, we're gonna set some n down here and some number up here. Let's just pick some random ones. Let's go with 8 up here, and let's go with 1 down here. Okay, and then that's followed by something in parentheses. Now, I am going to use a arithmetic sequence for this example. So let's start with, let's say 4 plus 2n. Okay, 4 plus 2n, which if you want to figure it out how that puts into the original sequence, okay, formula, you can kind of do that. I'm not going to do that right here. I'm just going to basically list them out. But basically, the summation notation here is just telling you what you're adding up, So this n is your starting n, starting term, okay? And then we have this 8 up here, which is your ending term, okay, last term. And then over here in the big old center right here, this piece is what you are adding, okay? What you're adding, how you get your terms. So let me show you how this gets expanded, because you're probably looking at this saying, I have no idea what you're talking about, Mr. Who. Okay, so if I were to input 4 plus 2 times 1, that is where my n equals 1. Okay, this is going to give me 4 plus 2 times 1, which is 6. Okay, hopefully you can do that. N equals 2 is then 4 plus 2 times 2, which should be 8. Okay, and hopefully you can figure out the rest on your own. I'm going to go ahead and just kind of power through them. But this should be 10, okay, and then so on and so forth. Okay, so it's like 12, 14, 16. You should be able to see the pattern there, right? Until we get to n equals 8, right? N equals 8. And then I have 4 plus 2 times 8, which is actually 20. Okay, so I'm missing one more in there. But basically, I'm going to take all of these numbers, let me circle these guys, all of these numbers, okay, and add them together. That's what this little sigma means. So when you see that in the problems on the IP, this is what I'm talking about. All right. Now, of course, if you don't want to do all this work about finding out every piece, because it's definitely not feasible sometimes, I will show you in a sec how to do that using the formula I gave you at the beginning. But first, let's go ahead and add these. Okay, you should be able to do this mentally, but if not, you can just go up to a calculator and add 6, 8, 10, 12, etc. together. So that's 14, 24, 36, 50, 76, or 66, sorry. We got 84, I think is what that one is, and then 104. So this should be equal to 104 in the end. Okay. Now, if you're wondering how to do it with the formula, okay, the formula again is S of sorry about that. S of n equals n times a1 plus an all over 2, if you remember that. Now, if you remember the formula for the sequence term, okay, I'm going to go ahead and use a different color marker for that. Okay, but essentially, you can say, okay, my a sub 1 is equal to whatever this is, 4 plus 2 times 1. All right, cool. And that should give me 6, right? That's what we figured out over here. And our a sub 8, which is where we're going to, is 4 plus 2 times, let's see, that should be 8 in here now. 16 plus 4, sorry, that's going to be 20. So undo, 20. All right, not bad, okay? Not bad so far. So if you look at this and say, okay, if I look at the formula, what I'm looking for is, let me change back to black, S8, okay, S8 equals our number of terms, which is 8, times 6 plus 20, those are my two terms on the ends, divided by 2. Okay, I've got 8 times 26 divided by 2, that's 13, I believe. Okay, and the end, you should end up with the same answer, 104. Okay, plug it into a calculator if you don't believe me. So this summation formula, okay, you can do it by hand if you really want to, if it's low enough, but in the end, the formula can tell you. So another way to kind of write this is that this sum, okay, from 8, n equals 1, of 4 plus 2n, okay, equals, okay, this idea of n, which is 8 times a1 plus a sub n, or a sub 8 in this case, sorry, over 2. Okay, so you can always use this formula to help get the summation out, whatever you're at. All you got to do is identify whether this is a arithmetic or geometric series, or sequence, sorry. Alright, so I'm here with the first problem we're going to look at on Delta Math. Okay, really the best way to kind of get into the swing of things is to see a problem being done on the IP itself. So here it's going to be called sum of arithmetic series. So I already should have that formula coming into my head. S sub n equals n times a1 plus an all over 2. Okay. And if you don't, you need to probably have that out with your notes so you can help yourself catch that. So let's take a look here. I've got my summation, my sigma, n equals 1 to 71, and here's my little argument, my little sequence, my arithmetic sequence there. Now, I'm going to need these terms, a1 and an, as well as n, which in this case is going to be 71. Okay. N equals 71. So when I'm writing it here, I'm going to be looking for s of 71, right, equals 71 times a bunch of other stuff. Now, let's go ahead and find our a sub 1. That's going to be out here. So when I have n equal to 1, okay, that should tell me that my 6 times 1 plus 1, that's going to give me 7, if I'm not mistaken. So this should be 7 plus, let's go ahead and find our nth term, which is 71, right? That's going to give me 6 times 71 plus 1. Now, I don't know about you, but that's going to be a little bit hard to multiply, so I went ahead and did it with a calculator before coming out here. That's 426 for those playing at home, plus 1 should be 427. Okay, 427. So this is going to be a pretty big number, it looks like. And that's why you do want to use the formula here and not want to do it by hand. And of course, you don't want to add 70 terms altogether. Okay. If you go ahead and simplify this a little bit, this is 434, okay, divided by 2. And if you divide by 2 there, it should be 71 times, that's 217. Okay. And of course, you're going to be multiplying that whole thing together. Let me grab the answer real quick. It's going to be 15407. 15407. Okay. Now, there isn't really a nice way to check, unfortunately, other than by trying to put it into Delta Math. So you're going to have to trust your calculator on this one. I'm going to trust my calculator on this one, and if I'm wrong, I'm wrong. Alright, but looks like my calculator was a pretty trustworthy this time. Alright, so that's a way to do this problem kind of in general. Next problem. Okay, so for this next problem, it's still an arithmetic series, so I kept that formula there. But it looks like we got a problem. We're starting from 0 and not 1. Okay, so there are going to be summations that do start with a different number, but it's going to be between 0 and 1 basically. So when I do write out my numbers, my n's, okay, I do have to consider that 0th term is the starting term. So when I'm looking at the formula here, it's no longer just, a sub 1. I have to account for that starting at 0. So this is actually going to be a sub 0. And then a sub n will have to have an a sub n plus 1 attached to it. A sub n plus 1 attached to it. Okay. So here's what I'm going to show you here. Okay. Again, I know my n is 75. I know my n is 75. But because I'm starting at 0, I have an extra number that is actually going to throw my n to 76. Okay. We'll throw my n to 76. So let's go ahead and put that in the formula. Okay. S sub 75. I'm still going to write 75 there because that's what I'm looking for in the end. Okay. Equals, Okay. 76, this is where that happens because of the n plus 1 out in front now. A sub 1, which is actually a sub 0 in this case. It'll be 3 times 0 plus 1, which is 1, I think. Okay. 1 plus, and then I have a sub 75. Okay. And that's going to give me, let's see, 3 times 75 plus 1, which that should actually be 226. Okay. All over 2. All right. And so with that, okay, I'm going to go ahead and simplify here. 76 times, that's 227 divided by 2. In other words, 113.5. Okay. And then again, use your handy dandy calculator, okay, to help you out here. All right, and I get 8,626. Now you should end up with a whole number since this is arithmetic and the the common difference is a whole number here, 3. So I'm going to put that in here. Submit answer, and we are correct. So if you are a little confused about why we have to start from a different number, okay, why we're using a different number out here than what's up here, it is again because of this whole idea that we're starting from 0 and we're not starting from 1. Okay, so be very careful. If you want to take a look at it here, okay, n they say is the number of terms, and that is going to be a little different depending on what the starting number is in the summation notation. Okay, now let's get a couple of geometric practice in since we've so far only done arithmetic. Alright, so here we are with the geometric series with sigma notation once more. I'm going to write that wonderful formula I gave to you earlier. Okay, it's going to be, whoops, sorry, I didn't mean to put n there. It was actually supposed to be a sub 1, okay, times 1 minus r to the n over 1 minus r. Okay, so there's our formula one more time. Okay, and I'm going to go ahead and take a look down here. Again, I'm starting at 0, so I have to again think about my n as being increased by 1. Okay, so be careful on that one. But let's take a look. I'm summing from 0 to 26 with this little geometric sequence, 400 times 1.26 to the n plus 1 power, So I'm just going to follow this. Again, I only need my first term, so let's go ahead and put that in here. My a sub 0 is 400 times 1.26 to the 0 plus 1 power. That should give me, if I can get my calculator here, 400 times 1.26 should give me 504. So that's my first term, 504. Okay. Now, what is my r? What is the r in this? Well, it's going to be 1.26. Okay, 1.26. So when I fill in the formula here, okay, it's going to be s sub 26, right, equals the first term, 504, times 1 minus r, which in this case is 1.26, to the n plus 1, or to the n power, which is how many terms there are. There are 27 because we're starting at 0. Okay, all divided by 1 minus the 1.26. Now, if this looks really funky to you, that's because it is. It's super funky, all right? But just bear with me here. You will need to use a calculator, of course, for this one. You may even want to consider going online to a calculator to have this do it for you, because there's a lot of steps in it. Okay, so if you mistype it at all in there, you might end up with a wrong answer. So I'll be back in just a sec to get the answer out. Alright, and I'm back. So after a little bit of plugging stuff into the calculator, I figured out that the numerator for this is negative 511.87, right, and the denominator is negative 0.26. That one should be easy enough. But when I put it into the calculator and figure out all that good stuff, I end up with about 992,234 with a bunch of decimals. It looks like 0.406 something something something. Okay, now this problem wants you to round to the nearest integer, so I'm going to change my color real quick. You don't actually need any of this stuff other than this last one so you can round up or down. I'm going to round down, obviously, since I didn't make it to the 5. But with this one specifically, with this section anyway, you are definitely going to want a calculator, and you're definitely going to want to check your answer a couple times before you do it. Okay. But when you plug it all in and all said and done, you should end up with something like this. Again, if you're not sure why I'm using the number 27 instead of the number 26, it has to do with our starting number, our starting index. Okay, if you start at 0, you're going to have to increment by 1 on whatever's on top to find your n, your total n. And then all you have to do is find your first term or last term if you're talking about arithmetic series, and then go from there. Alright, last here I want to mention this last section. You're only going to have one of these problems, but I'm going to get it started for you just so you know what you're looking for. But with geometric series in context, you're going to have to identify what pieces of the problem fit into the formula, which again, I kind of erased it, but I should have kept it. Okay. And then this is 1 minus r to the n all over 1 minus r. So if you're thinking about these pieces, I'm going to go ahead and underline them using specific colors here. Alrighty, and the last one here is our n. This is what your information you're looking for are. So let me go ahead and label the pieces in the problem. Small country emits 130,000 kilotons of carbon dioxide a year. In a recent global agreement, the country could agree to cut its carbon emissions by 3.1% every year for the next 10 years. So in the first year of the agreement, the country will keep its emissions at 130,000 kilotons. Okay, so the first year they're going to keep that. Alright, I'm going to mark that in red. And then they say they're going to decrease 3.1% in each successive year. Now, I'm going to underline that here. And finally, okay, how many total kilotons will they emit over 10 years? That's 10 years, starting with the first year, obviously, right? Now, I do have to mention that even though this says 3.1%, you have to take 1 minus this number, okay, as a decimal, okay, in order to get your actual R. Okay, this is going to be 0.969, I think. Okay, so that's what you would use there. But you're basically going to follow the formula, okay, and plug them all in as you see them, and hopefully you'll get your answer that way. Whew, this has been a pretty killer lesson, so if you definitely have any questions, please bring them up. Okay, go back and scroll back for the formulas again. They pop up all the time, but I guarantee you, okay, having them out in front of you will definitely help you figure out these series. This has been Mr. Who, and I hope you all have a fantastic day.